Hey guys, it's Mr. Win, and we're going to be talking about factoring quadratics when a is equal to 1. So our essential question, how do I factor quadratics, right? And if you remember, quadratics are your graphs, or you don't really have to draw this part, but I'm just going to sketch it a little. Of your graphs, they curve like this, okay? What you didn't really know is that quadratics, these curves, are actually two linear equations. So imagine like two straight lines, whatever they might be, multiplied with each other ends up making that curve of a quadratic. Okay, it's the product of two linear equations. And those two linear equations are what's called your factor form, your two factors of a quadratic. Okay, and I'll tell you what that means. If I have the quadratic x squared plus 10x plus 21, that is actually the same as two factors of x plus 3, x plus 7, two linear equations that are just multiplied with each other. They are both going to be the same. If you try to graph one and graph the other, right, they're going to give you the same curve, same parabola, all right? But let's talk about the standard form of a quadratic first. Standard form of quadratic always has an ax squared, so a being some type of number here. Okay, let's color code this. A being some type of number. Bx squared, just a bx, where b is a number, and then c at the end. So if you notice, okay, going back to our original problem, right, a is actually going to be 1, right? Because there's nothing in front of this. If there's nothing in front, it's going to be a 1. So when we talk about these quadratics, it's when there's no number in front. It's that understood 1, that invisible 1. But b is always changing. We have b here is going to be 10. And then we notice c is 21. Okay, it's even kind of in order when it's in standard form. All right. The only other thing to know is that standard form, that's also important, is when it is equal to 0. That means everything is on one side. So remember our original problem, right? Imagine this wasn't here, right? Nothing is on that right side. That's our original problem. That is a standard form, okay? But we're going to see how it does equal these two linear products of these two linear equations in x plus 3, x plus 7 multiplied with each other, okay? Because let's do the math out. If I actually multiply these, I'm going to use my double distribute where I take x times x, gives us x squared, and then I'm going to take x times 7, that gives us 7x. And then I go back and multiply the bottom part, 3 times x, 3x, 3 times 7, 21, right? I multiplied it out. It's expanded out, right? But then you notice, hey, there's some like terms here, right? I can combine a 7x and a 3x. That gives us x squared plus 10x plus 21. Isn't that the exact same? So notice how these two factors, this x plus 3 and an x plus 7, two linear equations, multiply them actually gives you a quadratic. Okay? And let's look at that here. If I go to the graph, notice, let's switch to the calculator really quick. All right, let's look at this calculator and bring out our original. Oops, here. Let's put it out here so we can see what we're doing. All right, this is our equation, x squared plus 21. So if I graph this, x squared plus 10x plus 21, all right, you get some type of parabola, right? Notice that? Now if you put in the equation and press tab to get a new equation, x plus 3 with an x plus 7, and it draws another line right on top of it. It's the exact same, right? So these factored form is actually the same, okay? So one linear equation can be written out to where there's a product of two linear equations, okay? They're the same. But I want you to look at that 3 and the 7. So let me move this out of the way for a second. Okay, our equation is x plus 3 and x plus 7. Oh, why not? Let's hide the first equation. I don't need to see it. We know it's the same, okay? But look at this equation for a bit. X plus 3 and x plus 7. You notice something, okay? 3 is actually 3 over from the 7. So if I grab my zeros here, remember to go trace, graph trace. This is how we would grab our zeros from a calculator. And I go down to the zeros. It looks like it started up here, but there we go. I got 1 0, right? Yeah, let's look at it better. There, we can see the actual whole parabola. Notice how one of your zeros is at -3, right? But mine says x plus 3 as one of my factors, as one of the linear equations, right? So it's probably the opposite of that plus 3, right? You got -3? Why don't we check the other one? If you can guess, it's -7. So your factors, your two linear equations, the x plus 3 and x plus 7, are actually just the opposite of your zeros, right? Instead of having x equals 3, x equals, or -3 and x equals -7, you would write x plus 3 and x plus 7 as two separate factors, whereas multiplied with each other, all right? Another neat trick I want to show you guys is if I actually just graph x plus 3, notice how it crosses your 0 at -3. And if you just graph x plus 7, notice how it crosses your other 0 at 7 as well. See how they're all related? Those zeros that actually relate to these factors, okay? They can be written. So if you know how to get zeros, you could actually write your factors, just x, and then the opposite of it, times another x, and the opposite of that as well, okay? Now let's go back to these actual examples, and let's do some problems, okay? Let's look at example 1. If I give you the factor x squared minus 11x plus 24, we could actually use that diamond method to figure out our two factors. We can figure out what two things that this would equal, all right? What two linear equations multiplied with each other would give us that quadratic. Well, I'm going to tell you now that you would place your c, remember that last number, as your top number, and you would place your b, -11, as the bottom number, and just figure out the diamond method, okay? So what two numbers multiply to give me 27, but add up to 11? Well, if you think of your multiples of 24, okay? You don't really have to write this out, but if I think of it, I have 1 times 24. That's obviously not going to add up to 11. 2 times 12. That's not going to add up as well. That's 14. 3 times 8. 3 plus 8 is 11, but it's a -11, right? So how about -3 and -8? Wouldn't that work out? Yeah, so that means your two factors would be x, and then I'm just going to put that number there, -3, and x, -8. Okay, those are your two factors. We have our factored form. And let's look at this again. I'm going to go back to the calculator. Watch what happens. Okay, so watch what happens. So if I clear this out, let's clear this out. If I graph that equation, pull that back up. Okay, if I graph that equation, x squared minus 11x plus 24, okay, there's your graph. We know that x plus, or if I did my math right, x minus 3 in parentheses times another x minus 8 should be the same, right? Because they're a factor form. And just to check, yeah, they are the same. But hey, look at this. Remember how to get our zeros? Let's graph trace over. Let's graph trace over until we grab a 0. So I know I got to go to the right. And a 0, oops, a little too far, is at 3. Hey, didn't I say one of my factors was x minus 3? Isn't that the opposite again of that -3 here? You see that? And the opposite, so if I can guess here, your other 0 would be the opposite of this, or the opposite of our two factors. -8. Yep, our 0 is at 8. So notice how that works out. So again, if you know how to get zeros, getting these factors aren't too bad, okay? So let's look at this again, go back to our notes. All right, so if I factor those, that means your factored equation will be x minus 3, x minus 8. All right, clean this up just a bit so you can kind of figure out what I was doing. Well, all right, so We have our answer there. That's a factored form. There's two factors to a quadratic, okay? So each factor, one would be x minus 3, the other is x minus 8. All right, let's talk about a real situation where I give you the area and we know one of the factors. What do we do? Well, example 2 says the area of a rectangle is represented by x squared plus 11x plus 18. If the height of the rectangle is represented by x plus 2, write an expression that best represents the base of the rectangle. Okay, so we have a rectangle. All right, we know the area. Okay, we know the area, the whole area inside is going to be x squared plus 11x plus 18. All right, but we also know that the height, let's say the height here, is represented by x plus 2. If I want to grab the area, right, wouldn't it be the height times the base? Right here, this is your height, this is your base, right? What is this going to be? What is that factor? So really, we can factor this. And if I factor this, you should get 2 answered. So you get 2 factors, x plus 2 and x, something, right? Some other factor that we don't know yet. All right, let's figure out what that would be. Okay, we don't know what this is yet. All right, well, if I do my diamond method and I place the c on top, here's the c, 18, and I place the b, 11 on the bottom, okay? What 2 numbers would multiply up to 18 but add up to 11? Well, hey, here's the thing. I already know one of my numbers. One of them is 2. Remember, that means that this number is going to be 2, right? What's the other number going to be? Well, 2 times what is going to be 18? 9. 2 plus what adds down to 11? 9. So we know the other number is going to be 9. We know that the other factor, let's erase this question mark, we now know it, should be x plus 9. So we know the base, okay, your base is going to be x plus 9 because the height is x plus 2. Okay, so this works the same way. We can use our diamond method. We can factor these, get 2 separate linear equations, because if I have one linear and another linear, they multiply equals to one product. Okay? The only other thing you might want to be careful of is if you have x squared plus, like, say, 7x plus, I don't know, 12, right? Well, actually, that works out too clean. Let's say 13. Don't forget, if you have a negative 1, everything should always go to the right side. So be aware that it should always be equal to 0. Put it in standard form first. So before you even do that, right, you would want to add 1, or actually that should be plus 1. Let's switch this example just so it works out. You would subtract 1 to both sides, gives you 12, equals nothing over here. And then you can start using your diamond method to factor, okay? You would have done 12, 7, and that's 3 and 4, x plus 3, x plus 4. Okay? That's it for the notes. So be aware you may have numbers at the end that you should cancel as well. All right, thanks.